So now we're moving on to building the LFS Cross-Toolchain and temporary tools. Linux from Scratch is built using a cross building technique. It's not a true cross-compile, as it says here. It does explain how it does. It goes into quite a bit of detail. It might take several reads of this to understand what's happening if you've never done cross-compiling before. I've even got a video of one at the front of one of my older sessions with an older Linux from Scratch. I can't remember. It might be version 10 because I think that's when this appeared. There's an explanation in there. I've done a slide which helps to understand how the cross-compile works. So you could look for that on my channel if you like. Look for Linux from Scratch 10.0. And it's one of the earlier videos that explains that with a slide, which might help to understand. There's some general compilation instructions here, so it explains the sequence of events you should go through, and you'll see me doing that. It just becomes repetitive. It will become second nature after a while. Particularly read these box outs here about the links, the symlinks that should exist. If you've ignored the host system requirements, then you're on your own, really. I mean, if something goes wrong, then it's normally the first thing I ask, did you follow them? Did it pass? Because if you haven't, you're potentially asking for trouble. And then it goes through the sequences for building each package. And as it says, just delete, once you've built a package, delete the source tree, even if you need to use it again, because then you can start afresh each time. Don't keep reusing the same source tree if it needs to be used more than once. So compiling across Toolchain, this is where we get stuck in and we actually do start building some of the software. So the first one we've got is Binutils 2.44. So the first thing we need to do is to change into the LFS sources directory and then extract the Binutils archive. Change into the Binutils archive, source tree, and then we can start following the instructions. So the first thing here it says to do is we need a separate build directory because that's what's recommended in the build documentation. And then there's a note here about timing these next instructions to find out how long an SBU takes. So we can do that using time, open curly bracket, put the configure command in, then a $, and the next command, which is make to compile the program, another $, and make install, which actually installs it into our temporary LFS system. Terminate that with a semicolon and a close curly bracket and wait for that to complete. I think on this machine it'll take a minute or two to run right through. Okay, so that's taken 1 minute 50 seconds. So that's approximately 2 minutes for an SBU. However, I think they say that the first SBU should be measured on one core, so you could argue that's about 30 seconds for one SBU. Based on that, it won't be exactly 30 seconds because, as I say, a lot of this, especially the configure command, runs on a single core, and there'll be other parts that run on just a single core, but as a general guide, 30 seconds would be a good estimate. So that's built. What we do now is go back to the sources directory and tidy up. And that's Binutils Pass One completed. Now with this, they've changed the layout of this page slightly. They've got a static header and a static footer. The footer being this slightly bluish grey bar. And there used to be a couple of links at the bottom for the previous page and next page, and it's not there anymore. And I used to recommend to scroll to the bottom of the page until you see those links and use the links at the bottom to ensure that you've read all of the page. But I've found now with this bar here, especially with the scroll bars disappearing at the side when the mouse is quiet, that sometimes you can think you're at the bottom of the page and you're not actually at the bottom of the page. So I still recommend scrolling down, but there's no visual clue anymore that you are at the bottom of the page. It would be nicer if this bar at the bottom here, this coloured bar, actually appeared just when you were at the bottom. It's a bit pointless otherwise. It's just taking up screen space that you could have another line of text on. And as I say, it doesn't give you a visual indication that you are at the bottom of the page anymore. So it's a bit unfortunate. It's from a usability point of view, I think it's a backward step, especially the links going missing. Yeah, so it's something that you've got to bear in mind, that you might think, for example, let's try and put that, you might scroll down with the wheel and think, oh yeah, make install, that's the last command, but you need to scroll down further to check there's no configuration to be done after the package has been built. So it's something to bear in mind. I'm trying to be mindful of it myself because I have missed it a couple of times. So let's move now on to GCC, extract it. Change into it, and then we can start with the instructions in the book. So initially it says the GMP, MPFR and MPC packages are needed, so that's what this is all about. Extracting these packages and then just renaming them to an unversioned directory so that GCC can use them. So just copy and paste each one of these, check that if the commands run okay and carry on. And then for 64-bit machines we need to run this. You can run it for 32-bit, as I said before, it won't do anything. If you're unsure, run it anyway. And then we've got to create a separate build directory again and start with this big configure command. I'm just going to change the scroll speed on this, it's a bit too fast. Apply. Doesn't seem to be doing anything at all. Oh yeah, that's a bit better. It's still jumping quite a lot, but never mind. Right, for some reason I can't change the mouse speed, but that's okay, and I don't think the scrolling speed is changing. No, I don't think that is doing anything for some reason. It used to be the number of lines it skipped, so that's the keyboard, isn't it? I think actually this might be the mouse. Oh yes, that makes sense now. Right. Let's try that. Oh yeah, that's a lot better. Okay. Right, so that's GCC configured. There's an explanation as usual as to what all those switches are and what they do. Let's now run make and wait a few minutes for this to build. Right, so that's finished after 21 minutes. I thought this would be quicker. So I had a look at top to make sure it was running on 4 cores, and it was. So maybe it's me just being a bit impatient. So that was the build. Let's now install the package. And it says here about a file does not exist, so the internal header has just been installed, is partial self-contained, but it's not good enough for the full build. It says create a full version of the internal header using a command that is identical to what the GCC build system does in normal circumstances. So let's do that. And that's that complete. So tidy up and move on to Linux API headers. So once again, first thing to do is to extract the tarball. And then change into the directory that's just been created and start running the instructions or following the instructions in the book. So we clear out the directory of any previous builds, run make headers, delete some files, and then copy the headers to the correct location. And that's done. So then move on to Glibc. Again, extract the tarball, change to Glibc directory that's been created, and then we start with the instructions. So the first thing is this case command, which does different things depending on the architecture. So 32-bit or 64-bit, both need to put that in. Then there's a patch to be put in. Create a separate build directory and change into it. Ensure that some utilities are installed in the correct place, and then run the configure command. And run make. It says it reports this package may fail when building as parallel make. If that occurs, rerun the make command with a -J1 option. I haven't seen that happen for years now. I'm wondering if that's still valid or not. Right, that's finished, so we can now install this. There's a warning there about if you haven't set LFS and your root that you could potentially mess your host system up. So I'm just going to double check that we've got LFS set, even though I'm LFS user. Yes, we have. So I'm just going to do the install. Okay, and we've got a set to put in here. And it says at this point it's imperative to stop and ensure the basic functions, compiling, linking, with no tool chain are working as expected. To perform a sanity check, run the following commands. So this creates a little binary, I believe. And compiles it, and then this looks for a string, and that should match with the book, which it does. And if you're on 32-bit, there's a slightly different output. And that's complete. So it says building packages in the next chapter will serve as an additional check that the toolchain has been built properly. If some packages, especially Binutils Pass 2 or GCC Pass 2 fails to build, it is an indication that something's gone wrong with the preceding Binutils, GCC or Glibc installations. So let's see how we go. So one more thing before we go on to the temporary tools is to build Libstdc, and that's part of the GCC package, so we need to expand that again. Create a temporary build directory and change into it, and then configure Libstdc. And then run the build, the compile. And install it. And then we've got a libtool archive to remove, and that's complete.